All right, good day. So, like I said, today's class is going to be one of those relatively short classes. It's meant to be an info session, if you will, just a reminder of what to expect in class theory test number 2, which is scheduled to take place on Thursday. Now, quite a number of things that I'm going to talk about were already highlighted in the info session that was held prior to class theory test number 1. So more or less like a repetition of what we did. And then I'll quickly gloss over the key topics where content from class theory test number 2 will be extracted from. If you have any specific questions as I am walking you through the info session, please do feel free and interrupt me. But again, it's going to be relatively short here. So just turns out I didn't export this and just export this thing. Time, and this was not supposed to be lecture series number 11, it was supposed to be number 16. I'm quite sure where the 11 came from, but this is supposed to be 16. Beautiful. Not that it matters, but the purposes of recording, I suppose, it would be nice if this was 16, not 11. Okay. Great, so this is tagged as guidelines really. It's more of an info session anyway. So like I said, the class theory test is going to be online, obviously, right? There's no way out here. It's going to be online. It will be available on Thursday, beginning midnight, all the way up to 23:59. And I mentioned that the time was changed from Friday to Thursday because we plan to have an epilogue lecture session on Friday. Now, I've sort of like heard rumors floating around that it's entirely possible that the semester might be extended. I'm not sure how true those rumors are, but if that's the case, right? If that's the case, then we shall cover the last 2 remaining themes, right? There's still the MIPS instruction set architecture that we are likely going to cover if classes do stop on Friday, and then there's a digital logic circuits lecture series that we're supposed to have. But I plan to briefly gloss over those 2 key concepts on Friday prior to the epilogue class, or as part of the epilogue class, just to give you an idea of what was supposed to be covered. It's unfortunate really that the confusion associated with COVID-19 led us down this path. But that's okay. I think we've done the best we could anyways. I would have really loved for us to discuss MIPS instruction set architecture and digital logic gates. But anyways, so again, the test is likely going to be an hour long, maybe an hour and 20 minutes long or something. But tentatively, just assume that it's going to be an hour long. And it shall include content covered until lecture series number 15, which is a lecture series that we wrapped up on Saturday, right? So data encoding. A reminder, right, in terms of how the lecture series are tagged in regard to the slides or the notes that you will find on the Moodle, the contents to expect in class theory test number 2 will include lecture series number 9, which was the input-output subsystem, right? Lecture series number 11, which was tagged as memory overview and primary memory. Now you notice that I've skipped lecture series number 10. Turns out that lecture series number 10 was similar to the interaction we're having right now, right? So it was one of those info sessions prior to writing class theory test number 1. Then we'll also have content from lecture series number 12, which was file organization and file systems. And I'll quickly gloss over these topics, don't worry. And then we'll also have lecture series number 13, which is tagged as computer storage, computer secondary storage. And then we'll have number systems and representation, really very basic math associated with those three different bases that we focused on. Although we primarily narrowed down on so-called base 2, or the binary number system. And then finally, we shall have content from lecture series number 15, which is data encoding. Right? All right. Again, just to remind you, I mean, if you take time and go through lecture series number 10, what you'll notice is that one of the initial slides has a list of topics that were covered in class theory test number 1. So we had content from lecture series number 2 all the way up to number 8, which is why in class theory number 2 we begin with content from lecture series number 9. Anyway, now that's not to say that we might not. That's not to say that we might not sneak in some ideas of what was covered in lecture series associated with class theory test number 1. But key thing here is that the content will be we include what was covered in the course, with the exception of what came in class theory test number 1. All right. Now, I'm regurgitating this because it seems this problem or the issues associated with these online assessments keep on popping up in almost each and every assessment that we write. Right? You have people that will utter very strange things like, I didn't know that I was supposed to submit the assessment. And this is during quiz, was that quiz number 14 or number 15? I'm sitting there and thinking, where were you? Right? When we were talking about these things, was administering all these different assessments that we've written so far. You know, so I'm just going to point out the same things that I've been pointing out, just in case there are people that keep forgetting here, right? If I were you, I would ensure that I figure out which internet service provider is going to enable me have a reliable and stable internet connection, right? This is extremely important. And again, my recommendation, and this is based on personal experience really, is you'd be better off if you have multiple phones or something with different SIM cards, just in case one network, you know, starts misbehaving. You can easily go with your plan B, which would be like the different network that you might have access to. Now the second point here will seem like a joke, but I had somebody write to me and tell me to say I was unable to I'm requesting. I don't know if that person was requesting for a makeup, and the reason they gave was that I didn't have enough bundles when I was writing the assessment. I'm sitting there and I'm thinking, are you really serious with life here, right? These are the very basic things that you need to make sure that you sort out before you attempt the assessment. There's a reason why we tell you weeks in advance when the assessment is going to be written. There's a reason why we explicitly tell you to say the assessment is going to be available within a 24-window period to enable you plan ahead, right? Again, this will seem like a no-brainer here, but you want to make sure that the devices that you plan to use to write this assessment are fully powered, right? Irrespective of whether you're going to check the ZESCO load shedding schedule and you discover that, there probably won't be any disruptions wherever it is you're based, but you want to make sure that they're fully charged. I do this myself. Before I sleep, I always charge my mobile devices and my power banks. In the event that I'm working from home, for instance, because the UNZA is not affected by load shedding, right? I'm not quite sure which grid we're connected to, but that place is rarely affected. But anyway, so if I'm working from home, I'll make sure that my power banks are fully charged. I'll make sure that all my devices are fully charged, which is why, irrespective of whether I have no power at home, I will always have classes. There's no excuse, right? Oh no, we can't have class because Lighton doesn't have power at home, right? That doesn't make sense. You know, Lighton is not serious or something. Right, so if you don't have multiple devices, the least you can do is find a friend maybe a relative, and explain to them how important this is. Ask them if you can borrow temporarily one of their devices so that you have at least 2 devices at your disposal. In the event that one malfunctions or runs out of power, you can easily use the other one, right? A reminder that if you find yourself in a situation where you're switching, right, from one device to the other, once you start attempting the assessment, the timer will continue ticking, right? So as you are context switching, you want to make sure that you quickly do that.
Sir, you're breaking.
Am I breaking for everybody, or it's just the person who was complaining?
Just mine is fine.
Yeah, so whoever you are, you want to check your connection. It appears you are the one with the problem. Intender here just told us that his is fine, so assume that the connection is fine. Unless if there's anybody else who seems to be experiencing what, I don't know if it was Kamfa or I don't know who was saying that, but all right. And again, the last point is extremely important because I saw a bit of a shock, especially in quiz number 15. I had quite a few of you that were reaching out to us to say, I never submitted my attempt, right? Now, I'm sitting there and I'm thinking, then why did you not submit your attempt? In each one of these most recent assessments, if you've noticed, you are given 10 extra minutes, grace period, not to answer the questions that are a part of the assessment, but for you to submit your attempt. This has been mentioned time and again. The grace period is meant to enable you successfully submit your attempt, whether you've managed to finish or not, right? But so you want to make sure that you explicitly submit your attempt, right? Submit all and confirm that you've submitted and double check that you've actually submitted your attempt. Very important. Right, so in terms of the content, just a reminder of the content that's going to be covered here from lecture series number 9 all the way up to 15 here. I know you probably still remember this, but we didn't really do anything sophisticated when we looked at the input-output subsystem. We started off by looking at the different views, the different view we can use to narrow down on specifics associated with
Dr.
characteristics. Yes, sir.
Sorry. I just want to confirm on the time the test will start. I'm sorry if you did send the email. Is it going to be open from 24 hours to 24 hours, or from the new normal, which is starting from 8 hours or something?
Yeah. So tentatively it's midnight to 23, but it will be open from midnight to 23. It's a 24-hour window period, but so it's midnight to 23. Or maybe we can switch it to the normal thing from 8 to, we've been alternating, right? Midnight, 8, 10.
No, I didn't see that one.
Yeah.
24 is very much okay.
Yeah, I'll send out an email if I decide to say maybe we'll stick to if people have gotten used to us starting at 18, but it doesn't matter really because it's the same window period, right? Whether we start at 8 to 8 or midnight to 23, it's the same window period, right? So if you feel comfortable writing the assessment at midnight, you can still write the assessment at midnight. If you feel comfortable writing it at 23, well, in this case, you could still write it at 23 or something. All right. So we looked at device characteristics here. We discovered that there's different ways of viewing these devices. Based on functionality, for instance, something that we started discussing in lecture series number 8, actually, when we introduced this notion of peripherals. We looked at characteristics of so-called block-based devices and bus-based devices. And then we spent time looking at the so-called, we started discussing the so-called I/O subsystem and touched on ideas or concepts associated with things like I/O controllers and their role, essentially. In terms of the I/O subsystem, our interest really was more on the key functions associated with so-called I/O controllers. And then finally, we wrapped up this topic by looking at the the techniques that are used to transmit data in between the peripheral and the CPU or memory, right? And vice versa, right? Looked at advantages and disadvantages of all these different techniques, really. And then we started our discussion of memory, right? And in this particular lecture series, we actually combined the overview of main memory with our discussion of primary memory. And something I want to draw attention to in terms of memory overview was the idea around the so-called memory hierarchy, right? That pyramid that we discussed. We started discussing it in this particular lecture series. We also looked at how we go about benchmarking the performance of memory components, right? How we go about measuring memory. And this is when we introduced measurables like bytes, for instance, right? I've always thought that maybe we should start doing the math way before we start talking about main memory, for instance. Maybe it would be much more, I guess maybe people would find it a lot more easier to understand some of these concepts, but that's fine. And then we look at different memory aspects, the usual, right? And I kept on mentioning, and I guess we're almost towards the end here, but I've been mentioning that the aspects we've been looking at are pretty much the same. If you look at aspects associated with the different categories of computer systems, aspects associated with the various generations of computer systems, and aspects associated with memory, you notice that these are the same aspects, things like size and cost and speed, right? Performance, essentially. So like I said, we also looked at the memory hierarchy. And then we narrowed down to specific types or categories of primary memory, right? By initially highlighting that we had already discussed registers, and so we didn't bother discussing registers here, but we started our discussion with CPU, cache, then went on to talk about ROM and RAM, and how they're different. And then finally, we concluded by looking at so-called virtual memory, right? And in all these different instances, we kept on mentioning the different memory aspects and the way the behavior of these memory components sort of like changes as you're moving away from the CPU or moving closer to the CPU. So again, cost, speed, size, right? In some of these, during our discussion of some of these subcategories of primary memory, we spent a little bit of additional time, like during our discussion of CPU cache, for instance, we narrowed down on the different types of cache, CPU cache that are available out there. And then during our discussion of file organization, we decided before discussing computer secondary storage, it was imperative that we discuss exactly how files or how data is organized on a computer on secondary storage, right? So we spent time looking at or discussing file organization and file systems, and really our interest here was more on trying to gain an appreciation of the different types of files that exist, and we realized that it's just two types of files: regular files and folders, right? And we know what the differences are. But in the process, obviously, we discussed trivial things like varying operations that can be performed on so-called files, right? So we can copy files, we can delete files, we can edit files, we can move files around. We also discussed so-called characteristics associated with files, right? This is when we initially introduced this notion of metadata, which is data that came back during our discussion of data encoding, right? So the different types of metadata elements associated with files, for instance, right? Trivial stuff, which we mostly know. And then we then talked about file systems, emphasized the fact that the file system is extremely important in helping organize your files on secondary storage, right? Typically, any secondary storage medium will have a file system associated with it. And we discovered that this file system will dictate exactly how files are going to be organized. So things like limitations associated with the length of the file names, limitations associated with the size of the files that you'll be working with, right? And by now, I think we've gotten to a stage where we know exactly how to evaluate the different types of file systems. There are so many of them, FAT32, normal FAT, file allocation table, right? XT2, all sorts of fancy things out there. And then we started our discussion of computer secondary storage, but by really looking at the different categories of secondary storage. So we narrowed our discussion on the broad spectrum of these categories here. So magnetic storage, optical storage, and flash storage. And then in the process, we also touched on, we discussed the variation that exists when you're comparing so-called DAS and NAS, right? So direct attached storage, which is usually storage that you directly connect to a computer system, and network attached storage, which is associated with things like file servers, cloud storage that has become extremely popular these days, right? So the likes of Dropbox, for instance, right? Right, and then we then briefly discussed a broad range of operations associated with secondary storage. So we looked at things like formatting, partitioning, backups, right? We spent a great deal of time on backups, and you notice that during our discussion in all these different topics, and it doesn't have to be the topics that are coming in CAS theory test number 2. There are certain topics where we're spending considerable number of time. Turns out that this is a more pragmatic and more important topics that will manifest themselves later on next year and fourth year, and in fact, once you get out there into industry. And then we wrapped up by looking at how exactly we get to evaluate different types of storage devices, right? So again, the aspects that we've been talking about over and over again came up, right? So you look at things like cost, and of course we introduced fancy things like weight and capacity. We discovered speed, right? And all these things, the decision on which attribute you're going to focus more on is contextual. It depends on what you're going to use that particular storage medium for, or storage device for. By the way, don't forget the difference between a storage device and a storage medium, right? And then we did a bit of revision from grade school, right? So we did a bit of arithmetic. This is not mathematics, it's arithmetic, it's addition and subtraction. It's what we're looking at here, right? Nothing complex here. So we started our discussion of number systems by really looking at focusing on 3 main types of bases on number systems, specifically hexadecimal, decimal, and binary number systems. And in all these different instances, we discovered that there are methods that we can use to convert in between the different bases. So hexadecimal to decimal, decimal to hexadecimal, hexadecimal to binary, binary to hexadecimal, decimal to binary, binary to decimal. So we know how to do these things. It's very trivial stuff, really. But the point worth remembering here is that at the beginning of the lecture series, we provided a bit of context here, usage scenarios where number systems are utilized, and we realized that in fact, prior to discussion of number systems, when we were talking about file organization, we briefly touched on number systems, right? Permissions in Unix take advantage of that, right? Although it's based on base 8, so to say, right? Oh, and by the way, something we did in this topic as well is we looked at the Unix file system as a case study. All right, and then we really narrowed down on binary number representation by focusing our attention on so-called signed and unsigned integers. We looked at specific techniques that are used to represent signed integers, right? So we looked at signed magnitude, 1's complement and 2's complement, and it turns out that your modern day computer system will pretty much use 2's complement. And we looked at the pros and cons, the advantages and disadvantages of using things like signed magnitude in preference to 2's complement, for instance, right? So remember our discussion of having 2 types of zeros, a negative 0 and a positive 0, something that doesn't really make sense, right? All those fancy things that we looked at. Yeah, and then in the mix here, we threw in things like very basic addition, subtraction, multiplication, and division of binary numbers, right? The test, if it does include a bit of math, I'm sorry to say your calculators won't help now because you only get full marks if you show your working, right? So you better learn how to do this between now and Thursday if you haven't. Cheating won't help you. All right. And then finally, we had a discussion of so-called data representation or data encoding, where we looked at exactly how the primitive data types get to be represented by a computer using ones and zeros, right? So we focused our attention on the things like textual representation, so text, then look at images, colors, video, sound.
Dr. Lido,
Yes, sir.
just on the issue of doing math calculations, it wouldn't be nice if someone decided to write around 24 hours and just to discover that you have to scan maybe your calculations and then post them online. So will there be issues of scanning documents or
Well,
while you
so
are doing your solution?
that option will be there. So you can scan, if you want to show a working, you can scan that. But also you can show a working in text, right? Lighton has been doing this using a text editor. You can copy paste if you think that's going to be a lot easier. But if I were writing this assessment, if I should write the assessment as well, it doesn't. I don't think it makes sense for me to write it. But if I were writing this assessment, I would probably show my working using a plain piece of paper. It makes more sense, much faster, it's much more efficient than typing. You can type if you want. You can even scribble, like I normally scribble here. If you think writing this 1, 0, like what I normally do sometimes, if you think this will help, then do it, right? And then maybe I don't know, but questions that will require that you show your working will explicitly have a statement say show your working, or full marks will be awarded for showing your working or something, right? Anyway, so we discussed these different data formats. We now know exactly how text is represented. We now know that images fundamentally make use of color representation because the pixels that make up an image will typically be represented using specified color intensity. So depending on whether you are working with black and white or a true color image, you get to use a certain bit depth associated with the color anyway. And we looked at video representation, where we discovered that video is nothing more than a combination of images and sound, really. So images that are presented to you in, successively, right, in rapid succession. And then we discussed sound representation, where we, I guess I don't know if my explanation of sound was very clear, but implicitly, I probably didn't mention this, but I latched on to what's called postcode modulation, right, where we discuss the 3 key concepts associated with postcode modulation. So sampling, quantization, and encoding, essentially, right? We discovered that sampling is extremely important because you need to determine exactly how many samples you're going to take in any given unit time. That unit time is usually a second. And then given a sound wave, something similar to this, for instance, you would have to make a decision, right, on what sort of bit depth you're going to use to quantize these values, right? So we discovered that the values that you get are normally associated with the bit depth that you're using. So if it's a bit depth of 8, then what you end up with is a situation where for each value that you're getting, it has to be as close as possible to either one of the values associated with that bit depth. So in the case of a bit depth of 8, it would be like 0 through 8 or something. And then finally encoding, where you just extract the zeros that represent, or that represent the rounded off numbers here. And then we discussed data compression, where we mostly narrowed down on so-called lossy and lossless compression, and looked at differences between the two. And indeed, examples or scenarios where you get to use the two, right? It makes no sense for you to make use of lossy compression when you're dealing with text, plain text. Why? Because the data is going to lose its meaning, right? It makes sense that you use lossy compression when you're dealing with data like sound, for instance, and video and images, because losing the quality doesn't really matter that much. You can still make sense of an image even if the quality is very poor, right? So, I mean, in summary, really, this is what we expect in class theory test number 2, which is on Thursday. And just to mention here, I don't know if you saw this, but I didn't mention it. We decided Wednesday, we're going to skip class on Wednesday, give you time to revise. Lighton will be available during that period. If you need Lighton, if you need to chat to Lighton during that 1 hour, let him know. And then, actually, I'll probably be logged on during that period, so you can feel free and log in into the meeting and then ask whatever question you might have on Wednesday. But we do have class on Thursday, which is our epilogue class. But like I said, if there's any change to the university academic calendar, then we shall continue and finish what we started. We must. I would really love for us to finish what we started. As I'm waiting for people to ask questions, I'm just going to open up lecture series number 1 to showcase what I mean here. If you remember, our Administrivia lecture series, which was the very first lecture series, at the end there, we did a breakdown of the different themes we're going to cover, but at the end was a very nice table, which showcased the things that we're going to cover and the approximate number of hours to be spent. What I'm saying is that MIPS ISA here and digital logic structures has not yet been covered. So if this semester is extended, we shall cover these. Okay, so if there are questions, I'm all ears. The floor is open if you have any questions.
Sam.
Yes.
So the question that was supposed to scan, the questions, are they questions or just one question so that we should get ourselves ready?
Well, so the setup is going to be the same or similar to what we had in the previous test, where if a question is an open-ended question, there's an option where you can scan. This is an optional thing. You can scan if you wish to scan, right? And this is mostly useful for people that have mobile devices. If you have a computer, it's very easy for you to type, right? But if you have a mobile device, maybe it's easier for you to just write down your solutions on a plain piece of paper, and then you scan that solution and then you submit it. So this is an optional feature. It will be switched on for all open-ended questions, and then you have the choice to either scan your solution and upload a scanned version of your solution, or just use that text area, right, and type in your solution. So the choice will be up to you.
All right, one more question.
Yes.
So the extension time that you give us to submit, will it be included in that 1 hour, or it's going to be 1 hour, 10 minutes plus the 10 minutes that we used to submit, or it's just in the same 1 hour?
Yeah, so no, it's outside of the 1 hour. So usually, I mean, the assumption is, if I were you though, I'd submit before the grace period. But ideally, the grace period is there to enable you to submit. And so it's if the assessment, the class theory test 2 is going to be 60 minutes, for instance, then the total time you'll be allocated is 70 minutes plus the 10 minutes of grace period. I don't know if I'm answering your question here, but
yes, you have. Thank you.
okay. Are there any other questions? All right. Well, if there are no questions,
oh, what's that? Wait. I think I've got another concern.
Okay.
You said it will be required to show our working. Like we're supposed to write down and scan.
No, I said no. I said if there's a question that requires that you show your working, it will be explicitly stated. So if it's not stated, you're free not to show your working if you wish. But if it's
Oh.
explicitly stated that you show your working, then you will be expected to show your working. If you don't, then you end up losing marks actually.
Oh, okay, sir. Okay, I get it. Okay, thank you.
Okay. All right.
Right. Yeah.
All right.
Dr. Lydon,
Yes, sir.
do we have time if you can go through that question under computer storage, the one which had calculations for differential and increment? Just that question, I think it would help if you have time. As in, I had to compare ones which were in the screencast, but I'm still not getting the concept. Maybe if we do that example, I might get a solid foundation on that one.
Yeah. Wasn't when the solutions provided for that thing? Did we not?
Yeah, they were provided, but the process as to how you came up with the answers was not provided.
Actually. Yeah, I guess we could look at that. Any other questions related to what I just spoke about here before we? What I can do is instead of doing this right now, I will create a screencast for that, a walkthrough, and then I'll post it. Is that fine?
Sir, can you read
yes,
the
that
chat?
would be helpful.
Their question.
Yeah. Why can't people just do what you guys are doing? I told you, context switching from the chat and. No, but the file format is always PDF, right? You have to be very careful here. We discussed this last time. File format is PDF. And in fact, the Moodle will be configured in such a way that it only accepts PDF documents. So you better figure out if you plan to scan these things and you're not going to use the Google Drive feature for scanning, which automatically converts your document to PDF, then you better figure out or find an application that's going to enable you convert your document from whatever image format you're using, maybe PNG to PDF. Yeah.
So.
And then Namuila here says, I'm lagging behind on, can I just finish reading this? I'm lagging behind on bit depth. How is it calculated? Well, you don't really calculate bit depth per se, unless it is a question that asks you to do the reverse or something. Bit depth is the value that is normally given to you, right? So if you're looking at color representation, for instance, the idea of bit depth implicitly tells you how many colors you can use to represent, that can be represented using that bit depth. So if you're looking at monochrome, it's 2, right? There's a bit depth of 1, it's either 0 or 1. If you're looking at true color, it will be 2 to the power 24, right? Because you're looking at RGB, each of which hopefully are represented using 8-bit representation, right? So this, you don't calculate bit depth really. I mean, same applies to sound. When you're discussing bit depth in relation to sound, you're essentially implicitly saying you want to specify, you want to use a specified number to represent those discrete values that you use to round off these values that fall within the sound wave here, and tools like Audacity actually will allow you to do that, right? So if you open up this tool, just using an example here, holding out here, and then you go to preferences, and then you go to quality. You notice that under quality, you get to, I guess, I don't know if it's here, yeah. You get to specify, right, the bit depth that you're using. So you don't calculate bit depth. There's nothing like calculating bit depth, unless if there's a trick question which allows you to do the reverse of something, right? So you're given certain variables, and then you are asked to calculate the bit depth, for instance. That does make sense, I guess. I don't know. Yeah. No. Okay. I don't know if this was a question here. Someone is laughing and saying maybe I might be the only one not getting. Yeah, probably the only one. Are there any other questions?
Yes, sir. Just a bit concerning.
Yes.
Oh yes. So, I don't know. I came a bit late, and I don't know if someone addressed this about. I wanted to play back the recordings, but I couldn't find the recording. But I didn't find clear on calculating the image size using the total pixel in the bit depth. I didn't really get the concept. I did manage to get the concept of how you find the total pixel by multiplying the resolutions, but then the whole how the 1 pixel is equals to 24 bits, so it's a bit depth in RGB. and how the 1 byte came in, I don't really understand, and how you did your conversions there.
But the byte is a measure. You need the byte, you need the 1 byte there, because you see, when you're dealing with images, right? We're saying an image has a resolution. When you're dealing with an image has a resolution. The resolution would dictate the number of, let's say you have a 100 by 100 image, right? 100 pixels by 100 pixels image, for instance. And then you're told to say this image is like, I guess it's represented using true color or something, which is like 24-bit representation. Right. So what we're saying here is that for you to be able to compute the size of an image like this, and of course we're making so many assumptions here, because if you look at the actual size and compare it with it, this would be the theoretical size. Theoretical size would be perhaps slightly large or something, right? So what we're saying is that for you to compute the total number of pixels, you just multiply the width and the height here, right? So this would be like 10,000 pixels or something. Right? And then what we're saying here is that each pixel, because you're using 24-bit representation, 1 pixel is going to be composed of 24 bits. And if you have 24 bits and then you have 10,000, this is 100. If you have 10,000 pixels, then how many bits are you going to have, right? It's direct proportion. So you compute the total number of pixels and then use the bit depth to determine exactly how many bits that picture is composed with, right? This is 24 times 10,000 here, right? And then once you get this value, this will be bits, right? Once you get this value, you know that 8 bits are supposed to ideally give you 1 byte. This is putative, right? It's agreed. It was agreed, right? Some people sat, some important people, smart people sat and agreed that 8 bits gives you 1 byte, right? So if you have this and you have 240,000 bits, then we could easily calculate the number of bytes here. Understand this? In this case, like the number of bytes is just going to be equal to 240,000 divided by 8, right? 241, 2, 3 divided by 8. And then you have 30,000 bytes. And then usually, I mean, if it's a trick question where you're required to convert this into like a more human readable representation, like maybe megabytes, then you start dividing this by 1024 to get kilobytes. This would be like 29 kilobytes in this case, right? It's not that hard. Does this make sense? Does this help? I mean, it's just playing around with direct proportion here, right? You know that each pixel is composed of 24 bits. So if you compute the total number of pixels, then you can easily compute the total number of bits that comprise of that particular image. Once you have the bits, then you can compute the size, right? Because all you do is you use this conversion here. We're saying 1 byte is equal to 8 bits. I don't know if that makes sense.
Yes, it does make sense. Thank you very much.
I don't know. Yeah, any other questions that people might have? Yes, sir.
Kindly post the recent lectures we had. First 2 or 3 lectures are missing on the Moodle.
Okay. I'll render those. I think I haven't yet pushed them to YouTube, and then they'll be uploaded. In fact, maybe I should do that right now. Any other concerns, comments people might have? All right, so if there are no questions, then good luck studying this. Last assessment, unless, right, and let's pray here. We're not praying for speed here, but let's pray for University Senate to decide to extend the period, in which case we'll have more assessments. It would be my wish for us to have a total of 20. If there's more time, then we shall have the 20 assessments, and then we shall finish off the last 2 remaining modules. That would be nice, I guess. I don't know what you think here. But if there are no questions, then I'm just going to have to say good luck studying. And if you need me to be online, I will most likely be online during the lecture series session on Wednesday. But if I'm not online, just let me know to say you want you need to chat to me about something related to the test, and then I shall go online. And I'll use the same meeting link to go online. In fact, maybe I'll use my phone to just be online for that particular period, the whole period or something. All right. Looks like there's a lot of stuff that hasn't been uploaded here, which is quite sad. Good stuff. All right. So then, if that's the case, I see this is this is 1745.
Sir,
Yes, ma'am.
sir, it's memory.
Okay.
Sir, I wanted to find out the first quiz that we had. The results are not showing on my thing, on my Moodle. Then it's showing 00. When I scanned the results I sent, but you didn't update them.
Okay. So we will have there'll be a major query session, most likely in the study break, once we are done with these assessments, where you get the opportunity to raise all these issues, because it turns out that once we're done with this assessment and during the study period, actually, the entire CA will be recomputed, and you get the chance to raise any issues. And in fact, I think I saw a question associated with makeups. Makeups, like I said, I don't know, is the previous session or something, sometime last week, mentioned that all people that qualify for makeups will write the makeups during the study period because of the confusion that's currently going on, right? You have people that are still deregistered, and so the last thing we want is we organize makeup for test one, and then some other person comes and they request for another makeup, right? To be impartial, we don't recycle questions. There are always different questions. So would much rather that people do these things as a group or something. So this will be, you'll be given the opportunity to raise these issues next week, actually, because study period, this is supposed to be the last day of class, at least as I checked anyways, unless if things have changed. All right. Any other questions that people might have? Something to be questions to do with the test. Yes, sir. Yes, Miss Madam.
So if we have any questions between today and Thursday, we can easily reach out to you and you will reply really fast.
Yeah, I don't know about the really fast here. My mailbox is quite full, but yes, I will, because of the assessment. It turns out the other course I'm involved with, they're writing the assessment on Friday. So yes, I'll switch on notifications on my phone. So I'll reply very fast. Yes. Between now and Thursday. Extremely fast. Just make sure you send it to the UNZA email address, not what some of you guys are doing by sending it to my personal email address. I don't check that as often as I do my UNZA email account. Okay. Any other concerns or questions that people might have? These things will be uploaded soon. All right. In transitioning to another class, best wishes as you prepare for test number 2. Good day. Bye. Don't cheat. You don't want to cheat. You don't want to do that, I assure you. You always get caught in life, right? Darkness. This lecturer who told me something I'll never forget. Darkness shall always come to light, right? You will be caught, and once you are caught, bad things happen, I assure you. Do not cheat. You know some of you are hiring people to do that. You will never survive the 4 years, I assure you. You will go down very, very soon. You're just delaying the inevitable. Bye-bye.
Yeah, those words of encouragement.
One shading.
I need to follow up.